Welcome back to the shrine. As you might remember from the previous video, this is the first failure of the forging process. That would have been the first tappet I forged. I was forging this pocket here, and it didn't turn out the way I wanted. One of the drawbacks of cooking this piece of metal in a kiln for 3 or 4 hours in an oxygen-rich environment is that it's going to generate a lot of mill scale. So these are some of the other parts that I heated up, and as you can see, the surface completely deteriorates because it just sits there in this high temperature oxygen rich environment, and it will just cook, and it will create a lot of mill scale. This is the mill scale. So essentially this is oxidized iron and some of the other alloying elements. So once you deform the part itself, this mill scale is gonna behave like a brittle case, and it will just flake off. As you can see, it will break into these smaller pieces. So there goes the dimensional stability of the part, because this was in your measured size previously, but once it flakes off, the size is going to change. So that's why forging is not a precise process. Besides the mill scale, you can also see that the surface color completely changed. So this is the part that got stuck on the tool, and I literally had to machine it off. So you can see the machining marks here. The part inside is still shiny, as you can see, but here where I cut it off and basically broke the hoop stress that was holding it on, it's all shiny in these areas. However, on the bottom and on the side here, you can see it's completely dark and black, and that is the carbon precipitating out of the surface. So this is steel. It's in particular 8620 steel, which means it's got about 0.2% of carbon. And so when it's heated, the carbon is going to precipitate out. It will come out of the surface layer, and that's why it turns black. And so that means that the surface layer will be deprived of carbon. It will basically turn into soft steel. That's the last thing I want to do, because I actually want to create a hardened case that will be resistive to wear and abrasion. So obviously this process of heating the parts up in the kiln and roasting them for 3 or 4 hours is not a good process because of all these consequences. So enter plan B. I had so many plan Bs over the years. This, my friend, is an inductive heater. It's made in China, and that is going to be the project for today. Absolutely no-name machine. You can find various incarnations on Amazon and eBay. This is the instruction manual, and made by Guangdong Haito Intelligent Technology Co. Ltd. It's in Guangdong Province, Dongguan City in China. That is the address. And the instruction manual is 20-some pages. First couple pages, they only talk about how it operates and what kind of other products the company makes. It talks about the voltage, and then the flow rate, how much flow rate it needs, but it doesn't talk about amperage, and that's a problem. So I looked some videos on YouTube, and this is rated at 15 kilowatts, but some people say it's closer to 5 kilowatts. And so if it's 220 and 5 kilowatts, that's about 23 amps. So I will go with that number when I'm sizing the cabling for it. It came with 2 of these coils, so I guess there's a horizontal one and there's a vertical one, and it also has a pedal. She's a heavy beast. Okay, so here's the back end of the machine. This is a cover. That's where the 220 has to be connected. That is no good, so I'll have to deal with that. There's a safety switch here. Probably disconnects both phases. And then we have 2 water ins, and then we have 3 water outs. Go and figure. That's also a ground here. So this is the 220 right up there, and this is where the ground is. I'm pretty sure it makes sense. There's also a fuse here. No idea how big it is. So the task in hand right now is to put all this together into a system, and we're going to need a chiller for that. Here's the chiller. It's made by Vevor. Doesn't have much to it. On-off switch. It's got a normal alarm, and there's a temperature gauge on that side. On the back end, it's got inlet and outlet. It's got a meter here that shows how high the water is. There's a drain. There's a optional outlet for alarm. This is the cord socket. So this is 110 volts, and it pulls about 0.6-0.7 amps, and the maximum pump lift is 8 meters. So it doesn't give you the pressure, the maximum pressure it's able to deliver. It doesn't give you the flow rate. According to the manual, the flow rate is 3.7 gallons per minute. So that would be 12-13 liters per minute, which is pretty high. They call this chiller, but it doesn't have that kind of thermodynamic components inside. I think all it is just some kind of radiator inside. It's drawing air across the radiator, and there's a pump. I think I'm gonna go inside and see how the parts are stacked against me. Just as I said, basically we have a radiator here that, you know, is in front of a fan. We got these lures on the side, so the fan is drawing the air in one way. Air is coming in, goes through the radiator, picks up some heat, and then exits at the back end. There's the pump. There's a power supply right on the bottom, so if it gets flooded, you know, it will fill that. Here's a tank. It looks like a 2 or more gallon tank, and then you can see the tank is plumbed into this meter in the back, so that is showing from the outside what is the water level. Here is the electronics that shows the temperature, on-off switch. So as far as it goes, it's pretty simple. They call it industrial chiller, but I think that's just to spice up their product. Again, it will just keep the coolant at room temperature. That's what it does. It radiates the heat into the room. it's not sending it into a parallel universe. Now I plugged it in, and when I turn it on, the alarm is beeping and the motor kicks in. And what I realized is there's a little device here plumb right on the bottom of the tank. So I think if there is no water, this device is sensing either the presence of the water or the temperature of the water. But somehow it is sensing that there's no water in it because I didn't put water in it yet. This chiller is being used for lasers, and some people use it for fish tanks. So when you look for it in Amazon, those are the typical uses that you will see. And it cost about $180. Just wanted to point out a couple interesting things. So first of all, it's got these clear plastic lines, and as you can see, the line is glued in with some kind of adhesive to the port. I think this is a return line, and then there's a zip tie on it. So everywhere I look, this thing is assembled with zip ties. Okay, so if you have leakage issues, that's maybe where you want to start looking. So there's zip ties everywhere. Every little connection has zip ties. I'm not saying it's not good, but it's a thermal device. Also want to point out again that the connectors here, these are not brass but plastic. I was shooting for one with brass, and I remember that on the pictures it showed as brass, but these are not brass, these are plastic connectors. Next item on the list is this cart. It's all black, so made by Performex from Menards. Harbor Freight has the same cart for $44. I found this in Menards for $32, and this is for welding, and I'm gonna reconfigure it a little bit. So this plate here, so it would sit in the back, but instead I'm gonna put it on the top. So that is gonna hold the inductive heater. This plate that would typically sit on the top, like so, I'm going to use it in the back. This flange has to be bent back that way because that is going to be a load carrying part of the cart. A lot better. It's about 2.5 hour close fight. This is where I am right now. I took apart the 2 phase leads from the insulator, and then I created a notch on the insulator. So this way I can bring the ground stud from here up into the box. So here's the ground stud. I can insert the ground stud. I clean the paint around it. I can insert it like that, tighten it up, and then I can put the box on. So this is just a standard 4 by 4 inch box. I bought this cable relief, and it's bolted into the box. It will be pointing down, so I can put it in there like so. And then the insulator is gonna hold the 2 wires from the back side like this. So I think that will be a lot safer option than what we had there previously. And it will include the ground stud also. I think I need to remove the stickers from this one and then just put it on a plastic. As you can see, I mounted the cover. I'm using the same fasteners here. There's plenty of clearance between the fasteners that mount the cover and the terminals. You know, I have the ground up here, so initially it was down here and I moved it up so it's in a box. There's a cable strain relief here, and then the other side you can see the ground terminal. I made room for it, so everything kind of worked out. And in the same time you can have a look at the guts, how the internal parts look. So you can see these are the inlets. So there's one inlet right there going to here, which is the coil itself. And there's another inlet here that goes up into the transformer. So the transformer has these coils inside. You see, so it's a hollow. There's some residual glue. So it's a hollow tubing that is put into the transformer, and it's being cooled, actively cooled. And you can see there's some extra pipes here going around the transformer, which is also being cooled. And then there's one here, this little pipe that goes up there, and it is cooling. I think this must be the primary coil on a transformer. You can see this is where it comes out. These are the, I believe, the Infineon switching devices right there. That's a big capacitor, some transformer, a bunch of electronics. So you can have a look from this side too. Went to the store and I asked for deionized water. And I understand my English is not perfect, but you should have seen that look on a clerk's face. What? Deionized. Deionized water. What is that? Well, it's water that has some ions replaced or changed. They got no clue. The closest I could get was this distilled water by Glacier Mist. It's 1 gallon, and I'm gonna run with that. It says processed by steam distillation is what we need. Hopefully this doesn't have any minerals in it that would clog up some of the arteries inside the machine. So I put in 2 gallons and it was about halfway here. But you can see when the system is filled up, it goes down to the alarm. So all the way to the lower setting. The pump is pretty quiet. It is running the coolant. You can see there's an air bubble here. That's on a return line. Then there's air entrapment. There's air entrapment on this line. This is the inlet. So the inlet splits into these two. The inlet splits into these two, and you can see a plurality of air bubbles here. And then this is the return, this is the outlet. It is running, it's showing the coolant temperature, 19.9 degrees. Boss, we're gonna need a larger pump. When I turned it on, it kept beeping. The induction heater just kept beeping. I read the manual early on and it says minimum pressure 17 psi, and the chiller doesn't specify what pressure it will provide. It shows how much head it's going to provide. I think it's 10 meters head. It's really not enough. So what I did here is I plumbed the gauge into the inlet, the water inlet, and you can see the chiller only provides about 3 psi of pressure, and we actually need closer to 20. So 17 is the minimum, but I think if I get something that provides 20, that would be good. So we need a bigger pump. You remember that pump from about 1 year ago? That is the RV pump that I did a teardown video for. So the turn-off pressure on it is 55 psi, and I put a gauge here that shows the pressure in the system. You can see the system is pressurized. I turned it on earlier, so it's sitting at 5 psi. I don't quite understand that part, but let's turn it on. So you can see that it jumps to 10 psi. That is the maximum this gauge can show. So it's higher than 10 psi right now, the pressure. So that pump is really boosting the pressure through the chiller. This is again just a test. So I'm going to put a larger pressure gauge on it, and look at that, we got a leak right there. We got a leak going. Spraying water on the electronics is always good. The little RV pump actually is providing 35 psi of pressure. So right now the chiller is connected in series with the RV pump, and I just use a laptop power supply to power the RV pump. But you can see it's pushing 30-35 psi pressure. It's a nice little package. I'm really happy with it. Fits onto the welding cart. As you can see, I can roll it around. Doesn't take up much space. I managed to install the booster pump behind the chiller. It is in series with the chiller, and there's the power supply for the pump. Again, it's a laptop power supply, works fine. Overall, it's a nice little package. So let's fire it up, see how it works. 40 seconds to red hot. I don't think my kiln can beat it. This is a lot faster way of heating up that metal, and there's no scale on it. Hope you guys like the video. Please give me thumbs up, and if you like the channel, please don't forget to subscribe. See you next time. Bye.